Hello, my fellow strawmen, and welcome back to the Fields of Hay. Today, I want to address a point of confusion that seems to crop up in many of the discussions I have with theists. They seem to think that science says that the universe was created, and that the Big Bang represents not just a starting point of this current form of the universe, but a starting point of everything altogether. But that is simply wrong. Science says no such thing. And in this video, I want to go over the pieces of evidence that I am aware of for the Big Bang, the conclusions I draw from them, and most importantly, how absolutely illogical I think it is to say that there was literally a Creatio ex nihilo moment which started our universe. The first piece of evidence I would present is one that has been known for hundreds of years. There is finite energy in this universe, and many ongoing processes convert some stored energy into thermal energy, lost forever to the environment. This can be summed up with the first two laws of thermodynamics. No new energy can be created, and as it is converted between forms, some of it must be lost as heat. The energy is spread out, unable to be utilized further. For example, our sun is burning through its definitively finite supply of nuclear fuel, and based off the size of the sun and its energy output, it could not be more than a few tens of billions of years old. In general, it can be deduced that the many processes we see could not have been going for an infinite amount of time, otherwise our universe would already be in heat death. Since we are not in heat death, entropy increasing events have only been going on for some finite period of time. The second piece of evidence is the redshift of distant galaxies, indicating that they move away from us faster the further away they are from us. This corroborates the conclusion from the first piece of evidence. Since these galaxies would be infinitely far away if they had an infinite amount of time to move, and we would be unable to see them, then they must not have been moving away from each other for an infinite amount of time. There was a point finitely in the past where all the matter of the universe was collected together. The third piece of evidence is the spread of the galaxies themselves, which appear to be scattered according to a uniform random distribution. That is, they are distributed in a way similar to scattering grains of salt onto black construction paper. They are distributed both isotropically, so roughly the same in all directions from our point of view, and homogeneously, roughly the same in any given patch of space. Taken together, these two properties would support the idea that our galaxy is nothing particularly special. In other words, the cosmological principle. Although our observable universe has an edge and is centered on us, the universe as a whole has no edge and no center. The cosmological principle also gives further context to the second piece of evidence. It isn't that all galaxies are moving away from us, it's that all galaxies are moving away from each other. Already an image of the Big Bang emerges. Before stars and galaxies started to form, the matter was spread uniformly and incredibly densely throughout the cosmos. It was also incredibly hot, and so following the laws of thermodynamics would have expanded and cooled into a state from which slightly overdense patches could start to collapse into stars. However, work is done by a gas on its environment, and the astute among you may notice that the universe, not the observable universe, but the actual universe, has no environment, no outer boundary encompassing it. How then did this expansion happen? The hot, dense state should have been eternal in a stable equilibrium like the core of a star, unless, of course, space itself could expand. I will come back to this point momentarily. By following the laws of general relativity and thermodynamics back in time, one can calculate specific properties that the early universe must have had, such as how long it would spend in a state in which it was cool enough for quarks to condense into protons and neutrons, yet warm enough for simple nuclear reactions to occur, about 17 minutes. Specific ratios of hydrogen, helium, and lithium would have been formed based on the density and timeframes involved. Armed with this prediction of the model, we can understand the fourth piece of evidence. When we take the light from the furthest objects we can see and split it using a spectroscope, we can read the spectral lines to determine the chemical composition of the matter that emitted that light. The composition we find in the early universe is an exact match to the prediction made. Finally, then, the coup de grace. There is a second prediction made by this model based on the properties of this mostly hydrogen mixture as it cooled in the early universe. Immediately after nucleosynthesis, it would have been a hot plasma which interacted strongly with light. Any light emitted at this time would get reabsorbed quickly, in thermal equilibrium with the matter. This would have continued until the plasma expanded and cooled enough for something called recombination to occur. The electrons were finally able to bind to the nuclei, the ionized plasma became a neutral gas, and over a short period of time, whole swaths of the universe became transparent. Light which had been in equilibrium with the plasma suddenly found itself traveling freely through space. Any of this light which started its journey at the edges of our observable universe is just now reaching us. Now we would expect this light to be a nearly perfect blackbody spectrum, representing the temperature of the transition point from plasma to gas. However, if we include the idea that space itself has stretched over time, then the wavelength of this light would be stretched out as it traveled, effectively cooling the temperature of the spectrum. Based on the pieces of evidence already discussed, and in particular the temperature at which recombination occurs and the amount of inflation since this moment, scientists can calculate what this cooled spectrum should look like. In all directions, deep in the background of any other sources of light, we can observe the cosmic microwave background representing a black body spectrum of 2.726 Kelvin, exactly what we would predict. Variation in this spectrum at the microkelvin scale confirms the isotropy and homogeneity of the early universe. The very presence of the CMB confirms that there was once a hot, dense state which was expanding and cooling. And the redshift of the light confirms that the universe is expanding, not just in the sense that the cosmic horizon is receding at the speed of light, but in the inflationary sense that every region of space is expanding from every other region of space. What I can say then about the Big Bang is this. From some prior state, an extremely hot and extremely dense state emerged, on the scale of galaxies worth of matter spread evenly through every cubic centimeter of space, and at temperatures which make the insides of stars look cold. This state expanded and cooled, leaving traces in the nuclear ratios in the early universe and in the cosmic microwave background. Over the next roughly 13.7 billion years, stars and galaxies and planets, and eventually our own planet formed. Distant objects continue to recede from us and will do so forever as space itself expands. What about that prior state, you may ask? Oftentimes you'll hear it referred to as a singularity, some point of infinite density and zero volume from which the universe expanded into existence. However, if you talk to a physicist or a cosmologist, you'll more likely hear them explain that the singularity is just a mathematical artifact left over from general relativity, a theory we know to break down when in conflict with quantum mechanics. The singularity in question, both small and massive, should be described by both quantum mechanics and relativity in the same way, and yet it isn't. Surely one or both theories are wrong, and we may not know until we develop a new theory of quantum gravity. At the end of the day, the singularity is simply a placeholder for we don't really know. Furthermore, I'd like to explain what I call the C4 analogy. Imagine watching a block of C4 detonate in slow motion. The detonator is clicked, the line of det cord carries a small explosion to the C4, which then itself detonates. This detonation is an extremely quick change of solid plastic explosive with energy locked up in its molecular bonds to hot gas with most of its energy in the form of random high-speed particles. The expansion of this hot gas creates the shockwave and blast that we are all familiar with, which dissipates into the surrounding area. Eventually, the energy of the blast is distributed randomly as the temperature of the surroundings would tick up. Now watch the same explosion in reverse, perfectly tracing each particle back in time. You would see a shockwave coalesce out of random vibrations in the air, which would collapse inward, heating the gas inside it. By the time it was the size of a book, it would be the density of normal solid matter and glowing red hot. At this point, the hot gases should perfectly react with each other to reform the block of C4, using up the thermal energy of the gas and ending exactly at the temperature in the environment. Here's the catch, though. What if we didn't know about chemical energy and had no idea these gas particles could react to form a solid? We would think that the hot, dense ball of gas must have been preceded by a hotter, denser ball ad infinitum until we find ourselves with a singularity. If all we had was the evidence that some hot gas expanded, but we didn't know its source, would we be right to conclude that it came from a singularity? Or should we conclude that our knowledge only goes so far and we can't yet say why the gas expanded? The point of this analogy is that we don't know what forms energy might take under the quantum gravity regime. I suspect that as we rewind time, before a singularity is reached, there was some other form the energy took, and which was the source of the energy of the Big Bang. What then do I think is before the Big Bang, if not a singularity? The way I see it, the theories of relativity and quantum mechanics break down, but we have no reason to doubt the laws of thermodynamics. The first law says that energy cannot be created nor destroyed. This means that all of the incredible energy present in the Big Bang was already in existence, just in some other form. The second law says that energy cannot decrease, but in the context of this discussion, I prefer it in a modified form. As one looks backward in time, entropy cannot increase. This tells us that for any finite chunk of the universe, as we move infinitely back in time, even past the events we know as the Big Bang, entropy must either continue down towards negative infinity or plateau at some minimal value. Now, entropy is based on the number of states a given system can be in and can't be negative, and so the entropy must plateau at or before it gets to zero. One of the fundamental mistakes I see theists make is in thinking that the second law says that entropy must always increase, and leave out the possibility for the plateau. Worse, they may correctly recognize that entropy necessarily hits a minimum as you go back in time, and see this as contradictory to the second law. If entropy must decrease to keep going back, and entropy has hit its minimum, then there's no way to go back, and so there must have been a starting point. But this conclusion is based off a misunderstanding of the second law, and is clarified by realizing that it is correct to include the possibility of a plateau. There is one other point which we expect to see a plateau like this: the heat death of the universe. All this refers to is the fact that after all the stars have burnt out and all the black holes evaporated, what will be left is many cold photons spread out randomly through an empty universe. Entropy will reach its maximum, about 10 to the 121 of the Boltzmann constant. When this happens, time won't suddenly stop running. Everything will just get so spread out and the remaining energy turned to such useless cold radiation that nothing more will happen. Our universe, though it has a finite window of time during which things can happen, is bounded on both ends by these entropy plateaus in which nothing happens for an infinite amount of time. In both cases, things just are. The conclusion I see is that the Big Bang was not the ultimate stable state, the eternal plateau. Although the entropy of the Big Bang was far lower than it is today, it was not minimal. Namely, there was all this entropy in the form of random thermal energy, the hot part of the theory. If this energy were locked up in some form of potential energy, and the universe started cold and dense, then the entropy could very well be minimized. Perhaps the universe existed in some metastable, cold, dense state for the past infinity, until finally a quantum perturbation broke the symmetry, and the Big Bang released the energy into the expansion of the universe. I like to imagine how easily a black hole could form under these density conditions, and that the sudden collapse of a small pocket would cause the rest to heat up and inflate. But I concede this is purely my own speculation. Regardless of how accurate I am about the details of the preceding state, the conclusion of the evidence I see is that the Big Bang was an event in time, not a moment representing the start of time itself. There was a time, billions of years ago, that is very difficult for us to look beyond, maybe even impossible. The earliest state we know was extraordinarily hot and dense, but then went on to cool down and expand to something more comparable to today's cosmic densities. I do not know what came before the Big Bang, I can only speculate about it. And if a theist does not know what came before the Big Bang and wishes to speculate about a god, they have every right. But to make the definitive claim that the Big Bang is the beginning, and to further infer that some being must have set us into motion, seems like utter folly to me. To end, I'll pose the question to the theists. What evidence do you think there is that the universe had an actual beginning, and in the Creatio ex nihilo sense, not just the sense of the Big Bang? Bear in mind, this conclusion is in contradiction to the first law of thermodynamics, so I'm going to hold you to a pretty high standard. Can't wait to hear what you come up with, and as always, go read a fucking book.